Today, major U.S. airports are cities in miniature. More than 1.6 million passengers pass through them each day. While waiting for departures and arrivals, they read, eat, shop, work, watch TV, place a quick phone call to the office, and check their email. Some even surf the web. Everything that it takes to keep these cities running and the flights on schedule goes on busily around them. And about 1 billion pieces of baggage move through the system each year.
What's your destination today?
Orlando.
Ah, Mickey City, huh? You gonna go see Mickey?
Yeah, and my grandparents.
All right, I call that a good reason to get on an airplane. Let me ask for ID, please.
Yes, sir.
Luggage has been under your supervision since you folks packed, right?
Yes.
Have you had any strangers attempt to get you to carry any items on board?
No, sir.
Of course not. I'll be right with you. 3 pieces. Okay, for the Jones family, we've checked a total of 3 pieces for Orlando, Florida, better known as Mickey City. You're going to gate C27 to receive boarding passes for the flight and also take care of your seat selection there. Thanks for flying U.S. Airways this morning.
Thank you very much.
Bye.
Thank you. Bye, sweetie. Take care. Have fun. Enjoy Mickey.
Her name is Maria.
That's a pretty name. Could you put on the x-ray machine?
Do I have to?
I just want to take her for a little ride.
It's okay, honey.
Look, she's fine. I think she actually enjoyed the trip.
Like a roller coaster, sort of.
Enjoy your flight.
Thank you. Bye.
Bye.
Why did Maria have to go on that ride, Daddy?
It's the airport and airline people, honey, trying to keep you safe and make sure that you're not bothered by bad people.
Muammar Gaddafi, Saddam Hussein, Osama bin Laden. Names we frequently hear on our nightly news. Right now, most of these travelers are oblivious to these names. They're more concerned with flight schedules, connections, business meetings, and greeting relatives. They're relying on the airports, the air carriers, and the Federal Aviation Administration for their safety and security. They can rest assured. Aside from the minor inconvenience of providing an ID, answering a few questions, and passing through a metal detector, much of the security activity is actually going on behind the scenes. It begins right here at the Aviation Security Laboratories in the FAA William J. Hughes Technical Center, just outside of Atlantic City, New Jersey. In this one-of-a-kind facility, research scientists, systems engineers, and human factors specialists work diligently to meet the challenge of countering the increasing sophistication of terrorists. These professionals are developing and applying superior technologies and systems that will prevent terrorist activities directed against aviation. Mandated by the Aviation Security Improvement Act of 1990, the FAA Aviation Security Research and Development Division is concentrating on rendering ineffective terrorist attempts to sabotage civil aircraft. Security is the largest single research and development program underway in the Federal Aviation Administration. Their goal is to strengthen aviation security through accelerated research and development, generating and disseminating technical knowledge, conducting applied research, evaluating product reliability, and testing systems for certification. To accomplish this, researchers focus on controlling access to the airport facilities, including the terminal, control facilities, ramp area, and aircraft. Identifying materials that present the greatest threat to the civil aviation fleet. Screening passengers, carry-on baggage, checked luggage, and cargo. Maximizing the performance levels of humans involved in the aviation security systems. And looking at potential future technological threats and developing effective countermeasures. In their approach, the FAA fosters close cooperation and participation with industry, other government agencies, academia, and foreign governments. This philosophy, the partnership of FAA, industry, and academia, is essential for successful development and deployment of airport and aircraft security systems. Everyone has a vested interest in preventing terrorism and helping to solve the technical challenges of aviation security. But the ultimate benefactor is the flying public. The FAA has divided the R&D program into 4 interrelated areas: explosives and weapons detection, aircraft hardening, human factors, and airport security technology integration. Research scientists are investigating current and emerging technologies to detect explosives and weapons to prevent them from being brought aboard an aircraft. These devices could be located on a person, in their carry-on baggage, in their checked baggage, in cargo, or through any other means. Consequently, the FAA addresses the problem through checkpoint, checked baggage, and cargo screening technologies. Checkpoint screening involves scanning people and their carry-on baggage to detect weapons, explosives, and the components of bomb building. Today's weapons are manufactured in a wide array of shapes and designs and are constructed of many non-metal working parts. Explosive material is malleable like modeling clay and can be molded in various shapes. New walk-through portals, enhanced detection systems, and handheld devices are being tested. These use a combination of advanced technologies to detect metal, weapons, and explosives. The FAA intends to eliminate the possibility of a terrorist concealing improvised explosive devices, weapons, or other threats. Checked baggage varies as much as the passengers who own them, and many of the items they pack trigger alarms. The challenge for the FAA is to detect, identify, and resolve these threats. Scientists are pursuing different approaches to explosives detection technology. These include X-ray, electromagnetic, and nuclear methods. X-ray techniques allow non-destructive inspection by interrogating the checked or carry-on luggage. Although there are variants of X-ray technology, it relies on the interaction of X-rays with the contents to reveal the image on a monitor. Since getting passengers to their destinations is a consideration, the maximum inspection time for luggage is about 6 seconds per item. This means that the FAA is testing for both highly sensitive and efficient systems, as well as fast and sophisticated data processing methods. Electromagnetic methods combine pulsed radio waves and static magnetic fields to probe the baggage contents. This technology is derived from the medical field and is based on magnetic resonance imaging, or MRI. Nuclear detection involves using radiation to excite or change the nuclei of the atoms in an explosive. When observed, the reaction of the nuclei provides a signature characteristic of the concealed explosive. Long-term basic research using nuclear technology can lead to better characterization of future threats. Trace technology looks for very small amounts or traces of explosive material left on baggage, electronic equipment, or clothing by someone who has handled explosives. Explosive substances tend to cling to a person and are easily transferred to anything the person touches. Trace enhances the more conventional methods the traveling public has come to expect, and it's already in use at nuclear power plants, Department of Defense facilities, and other agencies for explosive detection. Using this method has several advantages. It's non-intrusive. That is, the screener simply takes a wipe or vacuum sample and processes it, and it identifies the chemical substance making up the explosive. Trace technologies are also under study to collect particles and vapors from people, documents, and carry-on bags. Vapor sampling relies on capturing the volume of air that is swept over the passenger or article being examined. The collector then samples the air so that the detector can analyze the vapors for the signature compounds of the explosive. Particle detection offers a different challenge from vapor detection because the amounts emitted from modern explosives can vary according to type. The Federal Aviation Administration has already approved and deployed more than 650 trace explosives detection devices and 110 bulk detection units to airports around the nation.
Okay, that's us, honey. Are you ready for your plane ride?
Yep.
Okay, how about we pack things up?
Okay.
The FAA considers all contingencies. Being proactive also means being prepared in the event that, despite previous security measures, an explosive device still finds its way on board an aircraft. The goal of the aircraft hardening program is to protect the aircraft from catastrophic structural or critical systems failure in the unlikely event of an in-flight explosion. To accomplish this, experts are attempting to identify the minimum size explosive that would result in a loss of aircraft and determining the methods and techniques to apply to the current and future fleet to decrease the level of vulnerability. Two promising areas are the development and use of hardened luggage containers and enhancing the structure of the fuselage to withstand the blast effects of an explosion. In 1988, Pan Am Flight 103 fell victim to explosives hidden in luggage in a container in the cargo hold of the Boeing 747. Since then, the FAA has tested numerous full-scale prototypes under explosive conditions. Experts have successfully determined the amount of explosive material that a hardened container could reasonably expect to withstand without catastrophic damage to the aircraft. To date, one hardened luggage container manufacturer has successfully met both the explosive resistance and airworthiness specifications and is being operationally tested by the airlines. Meanwhile, research is underway to consider hardened units for use on narrow-body commercial aircraft. Determining aircraft vulnerability is a huge undertaking, combining research expertise from around the world, including the Department of Defense, private industry, aircraft manufacturers, advanced materials experts, and international partners. Since 1991, over 70 explosive tests on numerous actual aircraft fuselage types were conducted with emphasis on structure, systems, flight controls, and aerodynamics. FAA continues to work with U.S. aircraft manufacturers to determine the exact effects on the current and future fleet. In addition, the FAA investigated the vulnerability of overhead bins associated with carry-on luggage. To achieve realistic results, a narrow-body aircraft was pressurized and exposed to a small explosive in the overhead. Testing continues to assess the carry-on threat in a wide-body aircraft. This will result in new specifications in aircraft design to mitigate the blast effects caused by an explosive device. So far, we've concentrated solely on equipment, technologies, and systems, and haven't addressed the human being in the aviation security system. The Aviation Security Human Factors Program at the Technical Center is conducting research to improve human performance and behavior with respect to the entire security system. This includes personnel selection, training, performance assessment, and ultimately certification. Human factors specialists consider motivation, perception, behavior, and issues of health and safety. It's a formidable task facing the experts. Security problems and operating detection systems are quite unique. That's why the FAA is taking a systematic approach. Partnerships play a vital role and include international advisory groups, national laboratories, domestic airlines and airports, and research organizations. The emphasis is on enhancing screener performance and efficiency through better operator selection, training, and testing. This is being achieved through redefining the knowledge, skills, and abilities necessary for using the many current and emerging detection technologies. The experts are evaluating new multimedia computer-based training tools and monitoring systems, such as threat image projection, to aid screener performance. And researchers are providing input for rulemaking for certification of screening companies. Human systems integration means maximizing the performance of the man-machine system, especially when introducing new detection systems, such as bottle screening and millimeter wave detection. It also considers integrating new technologies into the operating environment, providing screeners with enough information to allow for the quick and accurate resolution of alarms. Each piece of detection equipment presents different challenges to the screener, airport designers and customers, and the flying public. Before a device is used in airports, it undergoes rigorous performance testing and evaluation by the Technical Center researchers. Not only must it meet the detection criteria, but it also has to pass operational standards and satisfy the requirements for reliability, maintainability, and integration. Field test trials at major airports ensure that all critical issues have been considered, evaluated, and resolved. This involves airport security technology integration. This area focuses on technologies that prevent unauthorized access to aircraft and airport facilities, and evaluating the impact on operations when introducing new security technologies in the airport environment. Technologies include perimeter controls, automated access systems, decision support tools, and passenger baggage matching systems that prevent unaccompanied luggage from being loaded into aircraft. To address these needs, engineers use various sets of tools: simulation for airport security analysis, modeling to integrate, improve, and reduce operating expenses, and identifying advanced threats that aviation may face in the future. Researchers have already evaluated the use of radio frequency ID tags for positive passenger bag match. The Airport Security Technology Integration Program has also developed a software vulnerability tool to assess airport security and identify areas for enhancement and advanced technical threats. Once approved or certified, the device can now pass to the Security Equipment Integrated Product Team. The SEIPT membership includes security professionals from the FAA, the nation's airports, airlines, and industry. The team works in partnership to purchase and deploy commercially available security equipment. This includes the installation, training, and testing, as well as setting operational standards for the new technologies. They're also challenged with determining the types and number of systems needed at airports. Researchers are striving to automate many of the detection systems to meet the demands of increased passenger flow while minimizing the cost. The Federal Aviation Administration is also looking towards the year 2010, when many of the detection devices are fully automated and integrated into one system. This integration goal seeks to produce a non-labor-intensive automated system that is less obtrusive to passengers and operations, where the impact is minimal and security assuredness is constant.
Hi!
It's so good to have you with us.
Yeah.
Did you have a good flight?
Yeah, it was fun.
Yeah? There's your mom.
The partnership of the airlines, airports, and the FAA enables the aviation security system to be constantly improved through new technologies and procedures. It's an evolving system built by caring, dedicated professionals. Passengers can rest assured, knowing that their air travel will be safe, secure, and their arrivals happy. The flying public arrive at the airport, go uninterrupted to their gate, unwind on their flight, and enjoy the peanuts.